Hello, we are glad to present a paper, OneFormer3D One Transformer for Unified Point Cloud Segmentation by Samsung Research. In our work, we address the task of segmenting point clouds. Segmentation means dividing something into meaningful segments. While there are a lot of possible options, only 3 formulations are currently adopted by the research community: instance, semantic, and panoptic segmentation. Yet, each segmentation task sets up a separate dedicated branch of research so that similar tasks are solved with different models: UNets for semantic segmentation, aggregation schemes for instance segmentation, and lifting 2D predictions into 3D space for panoptic segmentation. The question is, can we play simple and create one unified model, which can be trained once to solve 3 segmentation tasks jointly? The answer is yes. We present OneFormer3D for unified 3D segmentation. We use an instance segmentation model as a baseline and modify it to predict semantic masks as well. The information is exchanged across data modalities during training, which boosts the prediction quality in each single task. Our first novelty is flexible pooling based on superpoints, which are basically groups of nearby points in a point cloud. First, we calculate point features with a backbone model and average these features in each superpoint. These are our superpoint features. The number of superpoints is orders of magnitude smaller than the number of points, making our approach computationally efficient and scalable. Dividing a point cloud into superpoints has another benefit. We actually can initialize instance queries with superpoint features. A query decoder transforms each instance query into a kernel. Each kernel is convolved with superpoint features to produce an instance mask. So we have a correspondence between a superpoint, an instance query, a kernel, and a predicted instance mask, which defines a predicted instance. By skipping intermediate steps, we can directly match a superpoint and a predicted instance. Our model returns a set of predicted instances. We need to match predicted instances with ground truth instances and calculate their divergence to train a transformer-based method end-to-end. Previous state-of-the-art methods exploit the Hungarian matching. This commonly used approach seeks for the best combination among all possible matches between predicted and ground truth instances. An excessive number of matches makes the training process long-lasting and unstable. Previously, we established a correspondence between superpoints and predicted instances. Additionally, we assume that a superpoint can belong only to one ground truth instance. By bringing everything together, we can match a predicted and ground truth instance. The obtained correspondence disentangles the bipartite graph. That is why we call it disentangled matching. For a ground truth instance, we only need to select the proposal with the least cost, which is trivial. Our disentangled matching is notably more efficient than Hungarian matching and speeds up and simplifies the training process. We ablate our novel components on the scanet validation split. We only compare instance segmentation metrics, since our modifications do not affect the semantic segmentation part. Evidently, there is a synergy of our query selection and disentangled matching that allows for the state-of-the-art results. OneFormer3D outperforms single-task approaches on Scanet, Scanet 200, and S3 DIS benchmarks. Besides, OneFormer3D tops the Scanet test leaderboard. Here, we report results on the Scanet validation set, where OneFormer3D consistently improves all the metrics WRT previous state-of-the-art. In this paper, we proposed a novel transformer-based framework, OneFormer3D, that unifies 3D segmentation tasks: instance, semantic, and panoptic. We also formulated beneficial novel query selection and disentangled matching strategies. In extensive experiments on Scanet, Scanet 200, and S3 DIS, OneFormer3D established a new state-of-the-art in all 3D segmentation tasks while trained only once on a panoptic dataset.